All right, so here's a think, pair, share. Give this one a try, and then or stick around right now if you want to see me work this one out to help you out if you're having some trouble. So this is on crash test dummy head injury data with cars of various sizes. So listed below is head injury data from crash test dummies used in small, medium, and large cars. These measurements are in a standard head injury criterion. So use a 0.01 significance level to test the claim that different car categories have the same mean. All right. So let's look at step one, okay, which is our given information. Um, Now, what's a little odd about this one is that instead of having the categories, kind of like across the top, right, category one, two, and three, and then having all the data underneath it. Okay, here the data is now kind of tilted on its side and it's displayed horizontally. Okay, so on the Texas Instruments calculator, this is going to be list one, this is going to be list two, and that's going to be list three. All right, so you have to be kind of prepared to compensate for that. And with the NumWorks calculator, you also have to kind of reorient this vertically. Okay, and I'll kind of show you how that works. Um, so basically, what we've got is we've got a population mean of small cars. So population mean small cars, and mu m is the population mean of medium cars, and mu l is the population mean of large cars. All right, so our null hypothesis is that the mean for each of these is equal. Okay, that is our original claim. And the alternate hypothesis is that not all means are equal. All right. Um, let's see here. So we do know that we've got a significance level of 0.01, okay, which is a confidence level of 0.99. That's worth noting. All right. So we're really going to be able to compress this quite a bit and get this all on one page. Let me see if I can scroll down a little bit here. Okay. Trying to scroll down. Computer's not letting me. There we go. Oh, no. Okay. So this, I know, Serenity now. Let me go back up. All right. So the alternate hypothesis is that not all means are equal. All right. Let's go ahead and draw um, our F distribution. So we're just going to draw it like a chi-squared, and it's going to be right-tailed. So we're going to have an F critical value. Significance level, we were told, is 0.01, which means we got a confidence level of 0.99. This region is where we're going to reject the null. This region, fail to reject the null. All right, so to get this critical value, okay, computer is frozen. So I'm just waiting for it to come back. There we go. Switching to a green pen color. There we go. All right. So let's calculate this critical value based off of a 1% significance level. So I'm going to go to Programs, use the inverse F program. Okay, significance level of 0.01. Degrees of freedom of the numerator. Okay, so we don't have this yet. Could calculate this on our own, but let's quit this. All right, we got to run the ANOVA function first and get those values. So let's do that. All right, so what we need to do is go into the list editor, and I've gone ahead and put all of the small car data in list 1, medium car data in list 2, large car data in list 3. Okay, so you'll need to do that as well. So you can see like the data in the problem that was listed horizontally. Okay, so when you put in the calculator, you have to put it in vertically. All right, so let me quit out of this. And now we need to run the ANOVA function. So go to tests, it's the last one. And since I've got 3 lists, it's going to be list 1, comma, list 2, comma, list 3, right parentheses. I'll hit enter. Okay, and so we've got a F test statistic of 0.397 with a p-value of 0.676, and degrees of freedom of the numerator of 2 and degrees of freedom of the denominator of 27. All right, so let's go ahead and write that down. So what we've got is we've got an F test statistic of, let's see, 0.397 with a p-value of 0.676. Degrees of freedom in the numerator, I think that was 2, and degrees of freedom in the denominator, and that was 27. Okay, so now that we have these, we can run the inverse F function to get this critical value. But before we do that, let's, plug on over to the NumWorks calculator and run the ANOVA function there. Now, of course, we don't have that in the calculator itself, okay, but we have this MyOpenMath problem. Now, what you have to do with this one is, because you have to separate each column by commas, you have to kind of type it across, okay? So small, medium, large, small, medium, large, small, medium, large, and separate each column by a comma. So small, comma, medium, comma, large, carriage return, or enter. 406, comma, 502, comma, 216, return, right? And type it all in like this. And so if we hit submit, okay, here we get 0.397, 0.676 for p-value with 2 degrees of freedom of the numerator and degrees of freedom of the denominator of 27. So we get the exact same values. All right. So we got those values. Now we need this critical value. So I guess while we're here, let's go to the distributions app. And there's going to be the Fisher's F. There we go. Degrees of freedom of the numerator, that was 2. Denominator, that was 27. Right, 2 and 27, yep. And we want the area to the right with an area of 0.01, right? Significance level of 1%. Okay, we get 5.49 for a critical value. Okay. So let me put 5. Okay. All right, let me see. Oh, there we go. Okay. 5.49 for a critical value. Now let's just calculate this on the Texas Instruments, okay, because now we're ready to do that. Quit out of this. Program inverse F. Okay, 0.01 for the significance level. Degrees of freedom of the numerator, see we didn't have that before, it's 2. Denominator is 27. And the F critical value is 5.49. Okay, that's what we got with the other one. 5.49. Okay, so our test statistic of 0.397, well, that's going to be pretty close to 0. So I'm just going to put it right about here. So this is our F test statistic of 0.397. And so if we trace up from that, that's indicating we're going to fail to reject. And this area here, which is really large, that is our p-value. And our p-value is 0.676. And remember, if the p-value is smaller, reject the nuller. This is so huge compared to that. So we're not going to be rejecting the null. We're going to fail to reject the null. All right. So what we've got here, just waiting for my computer. Let me go. Okay, so what we've got is we've got that the null hypothesis was our original claim, and we're failing to reject the null. So let's scroll down just a tiny bit. Okay, erase that. All right, failing to reject the null, and the null is the original claim. So that's pointing towards this outcome. So now we'll write our conclusion. There is not sufficient evidence to support rejection of the claim that that different car categories, small, medium, and large, have the same mean. And that's going to be with a, let's write it with significance level. Should put that as a percentage. With a 1% significance level. There we go. All right, so we're able to significantly reduce the amount of space that we needed to do an entire hypothesis test here down to, less than maybe close to half a page. All right. All right. So let me know if you have any questions.